Hey folks, I just did example C and I realized I put a 4 instead of a 2 in one of my spots. So I'm going to redo this last example here. If you just bear with me. All right, so K represents the number 2 and G is right here. So I'm going to distribute the 2 as I go through. So this is 2x squared minus 4x plus 2. There was my mistake. I wrote plus 4 in our last video here. And x cubed is on the bottom. So again, anywhere I see an x, I am going to substitute a 3. So this is 2. 3 squared minus 4 times 3 plus 2 all over 3 cubed, and simplified all of this together gives me an 8 over 27. So I don't have a nice single digit integer. I have a fraction, but that's okay. I checked to see that it is in lowest terms, and it is, so that is okay. I'm going to show you another way that you can do this that might be simpler depending on what kind of functions you have. You could take each of these functions individually, solve them for x equals 3, and then multiply kg over h. So I could have done it this way. K of 3 is going to be 2. And why is that? That is because K does not depend on X. K is always 2 no matter what. So I could put whatever I wanted in there. It's still going to give me a 2. G of 3 is going to be 3 squared minus 2 times 3 plus 1, which is going to give me a 4. And then H of 3 is going to give me 3 cubed, which is 27. So then I could say kg over h is the same thing as 2 times 4 over 27. And you're going to end up with the same exact answer. So it depends on what kind of functions you have. Sometimes it's easier to just put them all together and then plug in the number. Sometimes it's easier to plug in the number first and then do the function computation. So up to you. In D, we have f times k. I'm going to erase some of my notes up here just so I can clearly see the functions. F times k of 1 minus h times g of 2. So this is where I'm going to use this method because it's going to get a little bit messy here. So f of 1 is going to give me 2 times 1 plus 1, which is 3. K of 1 is going to give me 2, and 2 times 3 is going to give me 6. Then I'm going to take h of 2, which is 2 cubed, which is 8, and then g of 2 is 2 squared, which is 4, minus 2 times 2, which is 4, plus 1, which is 1. And all together, this is going to be 8 times 1 is 8. So 6 minus 8 equals negative 2. And that is our answer for D. So this is an example where doing them individually and solving them would be a lot easier than writing all of this out and distributing it and then substituting the numbers that we have into it. Oh, and I see I wrote this as a 4, but I meant to write it as a 2, but the answer is still correct. All right, last example. This is what I would call a composition. Or sorry, not a composition. This is a more complicated one, but we have to follow the rules of BEDMAS here, right? We have H times F plus G, and this time we're not told a number. We're just asked what is the general form of this. So I have to be really careful about putting these together. F plus G, we actually did this in example A. So this is actually going to be function h of x times x squared plus 2, because we did this up here. So h of x is x cubed. This is x cubed times x squared plus 2. Or if you want to expand it, this is x to the power 5 plus 2x to the power 3. And there you have it. Okay, so we are using function notation, meaning we are using whole functions, but we are doing arithmetic. We are doing the standard math operations that we usually do on regular numbers. So in the next section, we are going to try to do this visually. So use the graphs of f, g, and h. So here is f. It's a shifted absolute value. G is a line, and h is a line. So here are my 3 pictures for this function. And we are going to find out what is f plus g of 3. Right here in our first example, f plus g of 3. Now remember that y equals f of x, y equals g of x. So what we are asking here is, what is y when we have x equals 3 inside of f and g? So if x equals 3, what is f? So we go to the f function. 1, 2, 3, 1. So f of 3 is -1, because that's the y value right there. If I go to g of 3, where is my y value? 1, 2, 3, +1. So if I add these together, I get 0. And that's all we can do. So this is what it looks like when we do these kinds of compositions, but graphically. So we should be able to do it visually, and we should be able to do it mathematically. And I just wrote this a little bit too big, so I'm just going to move it over so I have space for my other examples. I got really excited with my pen here, 0. So let's make a line here. Okay, next is h divided by g. So h of 5 divided by g of 5 equals, let's go to our h graph and look at what happens to y when x is 5. 1, 2, 3, 4, 5. 1, 2, 3 is our h, so that's our numerator. And for g at 5, it's -1. So what is 3 divided by -1? -3. Okay, f, g, h. So f of 1 times g of 1 times h of 1. Okay, let me erase some of my black lines here so I can see more clearly. H of 1 is -1. G of 1 is +3. And F of 1 is also -1. So 2 -1s cancel out, make a +1. Anything times 1 is whatever you started with. So this is 3. Okay, now it's asking us to graph f minus h of x. And we have a graph down below here that we can use. So what is f minus h of x? Now here's the issue. We don't have an equation. We only have a graph. So why don't we choose some values and put them together? Let's do an x and y. Let's do a table of values, the f function minus the h function. So let's do when x is -5. I'm going to go to -5. F is +5. H is -1, 2, 3, 4, 5, 6, 7. Okay, so 5, minus -7. That's 12. What if I did -2? At -2, this is +2. +2 minus, and then here at -2, I have 1, 2, 3, 4. -4. So this is going to be a +6. What happens at -1? I have +1 minus, where's our -1 here? 1, 2, 3. -3. So this is going to be a 4. Now, don't start looking for patterns because H is a line, but F is a V, so it's going to switch directions at some point here. So let's take a look at what happens at 0. Okay, F is at 0 and H is at -2, so this is 2. And where does F switch directions? F switch directions at +2. So let's make that our new point here. +2. That's going to say, okay, what is it at +2? F at +2 is -2 minus, and this at +2 is 0. So this is -2. Okay. And then let's skip a few. Let's go to +5 is 1. 5 is 1 minus, where's the 5 here? 1, 2, 3. So this is -2 again. Oh, interesting. Let's do another one. Let's say +7. 1, 2, 3. Minus, what's +7 here? 1, 2, 3, 4, 5. -5 is a -2. Okay, so it looks like after 2, all of our numbers are going to be -2. So let's plot these points. -5, +12. It's actually a little bit off our chart here. That's okay. We'll just pretend. -2, +6. -1, +4. 0 is 2. +2 is -2, and then it looks like we have a 2 that goes on and on. So we end up with a horizontal line here and a slanted line here. So this is the picture of f of x minus h of x. So we're taking the y values from f and minusing from h. And that's what we get. You can kind of see how this happens, right? We have positive numbers minus negative numbers. So we're going to get positive numbers because positive minus a negative is positive. And then we have some numbers here going up with a slope of 1. And this is going up with a slope of 1. So they're parallel lines. Parallel lines that means they have the same slope. So that means the difference between the lines is going to be the same all the way around or all the way across. So if the difference between them is the same, then we will have the same number no matter what we choose after that point. Okay, so here we want to look at f of x times g of x. And this one's a little bit trickier. So again, I need to choose a table of values here. And I'm going to tell you which ones I'm going to choose. I will start with -1, 0, 1, 2, 3, 4, 5, and 6. So we'll just go in order. The reason I'm doing this is because f and g are both kind of sort of linear, but not really because f is a V shape. So I'm expecting a polynomial here. It's not going to be a straight line. It's going to be some kind of a curve. So I want to make sure that I'm plotting points close together to see what the shape of that curve is going to be. So again, I'm looking here, what is the value of of f at -1? It's +1. +1 times g, 5. So this is going to be 5. At 0, f is 0, but g is 4. So this is going to be 0. Okay, so I'm zooming in and I'm looking at each point that I've just written down in my table of values, and I'm going f times g, the y values from f times the y values of g. And I'll let you double check my work, but I did this earlier, and you're going to get -3 here, -4 here, -1, 0, -1, and -4. So not really a very clear pattern here. When I go to graph it, -1, 5, 0, 0, 1, -3, and then 2, -4, 3, -1. You see the curve here is kind of going through 5, -1, 6, -4. So if I connect the dots, remember we always connect the dots from left to right. So you start with the 1 here, that's going down, and we're connecting the dots. And so this is kind of the curve we're going to end up with if I do f times g. And you can find as many or as few points as you want when you go through this example. Typically, I would suggest picking 5 points for sure, and pay attention to any critical points. And critical points is where you have a change of direction. I chose numbers around here because I have a change of direction right here. So I know it's going to affect the graph differently. This one goes in the same direction the whole time. This one changes direction. So I always want to make sure that I'm paying attention to what's happening at the points of changing direction. Okay, so here, again, we looked at points around that 0 and 1 mark for f. So here's what it looks like when it changes direction, and here's what it looks like when it changes direction when we multiply f and g. All right, so this is combining functions with either adding, subtracting, multiplying, or dividing. We should be able to do it numerically or algebraically. We should be able to solve algebraically given a number. There's 2 different methods that I showed you here. And you should be able to do it from a graph. Remember that the letters of our function, f, g, and h, they represent the y values. So you're going to use the same x for when you're solving stuff, and you're looking for the y values when you're looking for f and g. Okay, and that's the end of our lesson. You are ready to do your homework.